In this video, I want us to look at the sum of the geometric series, or the geometric sum. So the geometric sum is given by the following formula. Sn is equal to a times 1 minus r to the power n, all divided by 1 minus r. Or Sn is equal to a times r to the power n minus 1, all divided by r minus 1. So the only difference between the two is that you flip the r and the 1. You just take 1 to the other side and r to the other side. For both of these formulas, r must not equal 1, because whenever r is equal to 1, you will be dividing 0 by a 0. Let's do that. Let me prove that to you. So let's say your r is equal to 1 in this case, and you have Sn is equal to a times 1 to the power 1 minus, so let's say r is 1, and let's take n is equal to 5, right? And divide that by 1 minus 1, right? So simplifying this, we get a is equal to 1 to the power 5 is 1 to the power 5 is 1. So 1 minus 1, that's a 0. So 1 minus 1 is a 0. So 0 divided a times 0 is equal to a 0. So you have 0 divided by a 0, which in mathematics is equal to undefined. Let's now define each and every variable in this formula. In this formula, a is the first term of the series. R is the ratio of the series, or the common or constant. Remember, the ratio must be common or constant, right? Constant, common or constant ratio. And n is the position or the number of terms in the series. So now, I'll need you to remember that we have previously defined a geometric sequence using this formula. Tn is equal to a times r to the power n minus 1. Right, I will need you to keep this in mind at all time. All right, so let's look at an example to get the entirety of the idea of what a geometric series is and how to work around the geometric series. Okay, so let's take this example, right, as our geometric series, and we are asked to determine the sum of the geometric series, right? So remember, our formula is Sn is equal to a times 1 minus r to the power n all over 1 minus r, right? So in this case, we need to know our a, we need to know our r, we need to know our n, right? So we are not given what n is, the value of n we are not given, but we are given the last term. Remember our formula, Tn is equal to a times r to the power n minus 1. And our Tn defines any term in a sequence, right? And using this formula, we can find the value of n right there. All right, let's use that and get the value of n right away. So we have 5 over, that's our Tn, 5 over 128 is equal to a times r to the power n minus 1, right? So now we know the value of a, 128. We know the value of a is 40. We know the value of r is found by dividing the consecutive terms. That's r is equal to t2 divided by t1, or in general, tn divided by tn minus 1, right? So if we do that, we take t2 divided by t1, we get 20 divided by 40, which is equal to 1 over 2, right? So let's multiply by 1 over 2, all to the power n minus 1 because we do not know the value of n. That's what we are looking for. So now the next step is to divide by 40 both sides. Let's use a calculator for this. So it's 5 over 128, all that divided by 40, and we get 1 over 1024 is equal to 1 over 2 to the power n minus 1. All right. So now what we can do now, we can make the bases the same, both sides, in order for us to equate what? To equate the exponents. For us to be able to equate the exponents, the bases must be the same. Or for us to equate the bases, the exponents must be the same. When you have a huge number like this is what I would advise you to do. Firstly, take the square root of 1024. Let's work it out here. Take the square root of 1024. You have 1024, the square root of that is equal to 32. All right, so you know that 32 squared is equal to 1024. Use a calculator for this. All right, so try to write 32 in terms of 2, and that will be 2 to the power 5 is equal to what? To 32. Right, so now you know that you can rewrite this 32 as 2 to the power 5. And you can write 1024 here as 2 to the power 5. So 1024 will be, okay, let me write that here. 1024 will be equal to 2 to the power 5 times 2, right? So your final answer will be 2 to the power 10, right? So now you have 1 over 2 to the power 10 is equal to 1 over 2 times to the power n minus 1, right? So now remember that 1 raised to any number is always equal to 1, right? So let's use that idea to take this 10 out from the denominator. So now we have 1 over 2, all that to the power 10 is equal to 1 over 2, all that to the power n minus 1. Now you can see that the bases are the same. Since the bases are the same, we can equate the exponents, and the exponents will be equal to 10 is equal to n minus 1. Transpose 1 to the other side, and then you get n is equal to 10 plus 1, which is equal to 11. So now we have the value of n. Let's go back to our formula for the sum of the geometric series, which is Sn is equal to a times 1 minus r to the power n all over 1 minus r, right? So we plug in all the values. Now we have a is equal to 40, 1 minus, what is r? R, we said it was 1/2, all that to the power 11, which is our n, divided by 1 minus 1/2, right? So now you can use a calculator for this, and using a calculator we get that that's a 40 times 1 minus half to the power 11, right? All that divided by 1 minus 1 over 2. And we get the final answer is equal to 10,235, all that divided by 128. So this is our final answer right here. Right. So there is another thing that I want you to keep in mind, right? You need to know that your Tn is equal to Sn minus 1, right? So to prove this, let's go back to our given series, which is 40, 20, 10, and that was 40 plus 20 plus 10 plus 5 over 128, right? Let's say we wanted to find T3, right? T3. So what we could do, we are told that to find Tn, we must subtract Sn minus, we subtract Sn minus 1 from Sn, like that. So what will be our Sn in this case, because we are looking for T3? So our Sn will be S3 minus, what is Sn minus 1? That is, n is equal to 3. So our Sn minus 1 will be 3 minus 1, which is 2. So here's what you need to do. You need to, because Sn is the sum of so terms, right? So this means that S3 is the sum of the first 3 terms, right? So let's add the first 3 terms and get the value. So our S3 will be equal to 40 plus 20 plus 10. Those are the first 3 terms, right? So 40 plus 2, that's a 60, plus 10, that's, so 60 plus 10, that's a 70, right? So we have S3 is equal to 70. Our S3 is equal to 70. All right, what is our S2? S2 means the sum of the first 2 terms. What are the first 2 terms? The first 2 terms are 40 plus 20, which is 40 plus 20 is equal to 60. All right, so we have S2. S2 is equal to 60. So to get T3, we are told that we are supposed to subtract S3 from, we are supposed to subtract S2 from S3, right? So we know the value of S3. What is that? That's a 70. That's what we got. Minus S2, that's a 60. And we get that T3 is equal to 10. Is that what we were given? Exactly. T3 is equal to 10. That's what we were given. So that's another hack that you can use in your exams when you are, they're surely going to ask you these in tests and exams. So please keep that in mind. That's one thing that I just wanted you to know. Okay, thank you so much for watching, and please do come back for more videos. And in our next video, we are going to be talking about some of the infinite geometric series. Okay, thank you. Bye.